Welcome back. This is going to be issue number 5. And yesterday I ended on a note where I was trying to install GDB. And I was doing a sudo apt install build essentials, but that was not the correct name. It's essential with no S, password for atoms, and it's already installed. Now the program I was looking for was GDB. I did a which GDB, which is the GNU debugger, and it wasn't there, and so I had to install it. Now you see it's there now, but I did a sudo apt install GDB, and it says, nope, it's already in there. Something that I need to point out that you may have noticed or not noticed, and if you've been doing the exercises and if you've been using the computer, on the sudo, the first time you do it, sudo, you get prompted for your password. And the system has a way of checking when you type in sudo again, if it's within the last 5 minutes, it doesn't prompt you for the password until after that period of time has elapsed. It figures you're sitting there and you don't want to keep typing it in. I think it's time for us to check our updates, so it is sudo apt update. And we'll do our sudo apt upgrade. See, it did not prompt me for anything, and I get this little thing here. They want me to get subscribed to Ubuntu Pro, and it's probably a charged thing, and then there's the things that these following packages have been kept. Let's see if I try to, this is the fast Fourier thing. Let's see here. Let's do a sudo apt install ffmpeg. So anything that's kept back for some reason, I can install it. Okay, watch this. Let's do it again. Go back to here, do the update. Okay. System wants to play games with me. Okay. So what I'll do here is I'll do a sudo apt install, and now let's see. I'll go up here and highlight this. Right-click copy, right-click paste, hit return. Oops. So I screwed up my cut or copy. Go back here. I missed a D. Try it again. Want to continue? Yes. So I can go and do the minus Y. Okay. I'm not going to do that on your time, but you see that there is a way to learn something new. Going back to the mistake that I made in getting the package name wrong when I did the build essentials. It should have been build essential. There's a piece of software missing on the system. It's not installed. I've already installed it, but I'll show you how I did it. Sudo apt install GNOME software. It's a graphic interface that allows you to search through possible candidates for installation, and you don't have to know what it is you're looking for. Usually you don't. Okay, so you do an install on this and it says it's already installed. Now this is a graphical interface, so you go up here to Applications, go down to System, and there's a thing here, Software. A little icon is yucky, but that's okay. Bring it up, and you can search for something. If you like, let's say I'm looking for anything related to typesetting, LaTeX. So hit return, it goes and search, and then it finds all these little programs that are related to LaTeX. Okay. I can undo that. You can look at what you've installed. Okay. There's the partition editor, all these screenshot, simple screen recorder, which I installed, software updater, software and updates, and you can uninstall things that you're not interested in. Screenshot is interesting, and I'll demo it one of these days. So now there's a thing here, it does updates, and it says requires restart. So this is OS updates. Now this scares me because I'm not sure that this is related to the Orange Pi. So I'm going to do that offload. You would love to see me mess this up royally. All right, one other thing. Previously, we went to archive.org and we downloaded the C programming language 2nd edition. If you started learning C, or if you know C, then you probably read the book already, because it's just the standard starting place for learning C. And if you go back to archive.org and look for other C books, there's a whole bunch. I mean, you got the whole universe there almost. But in the C programming language by Kernahan and Ritchie, which everybody calls K&R, there are exercises. There's a bunch of them. And if you want to really become an expert on C, solve every one of them. But it turns out there's an answer book, and it's also available on archive.org. You have to search for it. Now, it's difficult to cut and paste or enter the programs, except somebody has done it for me. I did a search, and if you go to the Google search or DuckDuckGo, whatever you use, and whatever browser, do GitHub C Programming Answer Book, do a search. First thing up here is GitHub. This was done by Okamura, and it's the C Programming Language 2nd Edition solution. So if you go over here, you'll find out that, hey, there's files and directories. Let's go to chapter 1, and chapter 1, here's all the exercises, and those are in, there's 24 exercises in chapter 1, and it tells you what they are. This is, and there are comments here, what's done to this. But you do not want to spend all your time downloading or looking at each one of these individually. We can do it from the comfort of our own home. The way you do this is you go here and type on this little, left click on code, and it comes up with a URL that points to this material. Left click on it, that highlights it. Right click on it and do a copy. Okay, now you go back to your little terminal, and I've got C programming is our stuff. Let me just make a directory. solutions. Okay, I did this. Right protected, yes. Oh my, okay, want to delete something and it's right protected. I can do a remove -R. This is a directory, so do it recursively. Force it. Don't ask me if I want to. I'm going to delete this, and I don't care whether I'm right or wrong. And it does. It's one of those that commands you use carefully. Let me do a make directory solutions. CD to solutions. Now, whoops, wait. Oh, look at there. Why have I am a good typist. Doesn't show up here, but I do make directory solutions, CD to solutions. There's an install routine already on your system that comes with it, Git, which obviously is related to GitHub. And this says go out here and get it. Play on Southern slang, I guess. Git. I want to clone the material from the website. So clone, and then you right click and paste the URL. Okay. And then hit return. And it didn't take any time at all. And if I do an ls, I've got a directory, okay, showing that this is the second edition. CD to it. That takes up a lot of room, doesn't it? And there's all your directories, the license. Let me make this full screen. VI, the license, so you can see what your rights are. And this permission is granted free of charge to any person who obtain a copy of this to deal in the software without restriction, including without limitation, the rights to use, copy, modify. I'm going to go through these and I'm going to correct any errors. There's probably some. Merge, publish, I can write a book. Distribute. Okay, I'm going to distribute to you because I showed you how to get it. I can sublicense it. That is, I'll sublicense it to you for use or whatever, or I can actually sell it. Okay. I consider that somewhat. If I went into business and sold this, I'd go broke. Number one, but number two is that ethically I would give the original author who did this 2 years ago, I'd give him, a 15% finder's fee or whatever. Okay, so we can use this. And I provide it to you as part of the course to help you learn, see if you don't already know it. And if you know it, then there's some exercises for you to look at. Okay, enough of that. Okay, we're ready to start our first program. I ask you, politely I hope, to go out and look for all the information you could find on primes. And hopefully you did that. So I am going to, on my own initiative, write a program that finds all the prime numbers. Now, I'm not going to live long enough to do this, and I'll show you why. Let me make a directory. I'm going to call it, let's say this is, okay, we're going to do projects, so I'm going to call this project -001. Notice that in Linux, you can, names of directories, put in a dash. Do not put the dash first. I will do it, mate, because I know what to do. Minus project 001. It's an invalid option. Okay? because the make directory command is expecting some flags, and the flags are indicated with a dash. But let's say you really wanted to have a directory that started with dash. Well, there's a way to tell make directory to quit looking for flags, and that is to put a double dash. And voila, I've got a directory that starts with a dash. Now watch this. This will bug your neighbors and your enemies. Try to CD into project 001. It says it's an invalid option. That's because CD has flags that it expects to be preceded by a minus sign or a dash. And okay, I created this directory, but I can't get to it. No, not without the secret key. CD minus project, dash 001. Advanced shell. Okay, so I'm going to go back into project, the real project. Now, the way you should do programming is, first of all, understand the problem, number one. Number two, do any research you need to find whatever mathematics or engineering or whatever's needed to solve the problem. And then three, sit down and lay out how you're going to write a program. We're doing software engineering here. Let's see how I'm doing on time. I'm up to 17 minutes. Oh, I'm way ahead of schedule. Glory, glory. Let's see. So I'm going to do this on the fly here. I'm going to, in this project directory, I'm going to put, I'm going to edit a file called goals and pseudocode. Okay. First of all, project. Generate prime numbers. Okay. Now, I do not want to write a program that's going to generate them all because we will all not live long enough for it to complete. You don't believe me? Okay, I'm going to prove it. Okay. Program, what's the program? Program syntax, command line syntax. What do we want it to do? Well, what we want it to do is we want to type in the program name. Let's call it primes. And I'm going to set this up to take two parameters from the command line. One of them is the starting number, and the number is the ending. Start and end. Okay, because I want to generate all the prime numbers that are within this range. Because if I set the program up to start generating numbers and I output them to a file, how am I going to know where it is? Well, it turns out there is a Unix command that will allow me to figure that out, and I'll come back to it. But then I would have to just start the program, let it run, come back, and then do a Control-C, which says kill the program. And then it will stop, and then I can do whatever I want with the output file. Usually we're not going to write programs that generate output to the screen, or we can generate it to the screen If it looks fine, then we will run the program again and redirect the output to a file. Hopefully you are reading your shell programming book. All right. So we got the command line. So we know, well, we're going to have to figure out what do I want to call it? Solution. Okay. Test odd numbers, because the only prime number that's even is the number 2. So we're going to test odd numbers for prime. Status. Okay. If prime, then output. Else, ignore, and go to next number to be tested. Okay, and we're going to do this in a loop for I equal to start to end. Now that's not the syntax, C syntax, but that's just pseudocode. I'm gonna do this, and then test, and output if prime, and that's my whole program. All right, pseudocode. Well, hey, the pseudocode, see above. So we're ready. Do I have everything in place? I'll leave that as an exercise for the student. But I think that covers everything. How am I doing on time? Got 8 more minutes, and then I'll have my, well, it's not a goal. I'm not trying to kill off times here. All right, so let's start coding. VI primes dot C. Input. First thing you do in the C program is what? Include standard io.h, because I need to, print output. It would be silly to write a program that doesn't output anything. So actually nowadays that's not true, because I could write a program that does a whole bunch of number crunching just to put a load on my CPU. All right, main routine. It doesn't need to return anything, so I'll void main. I'm going to input the starting and ending numbers on the command line, so I'm going to have to use the standard C arguments to main to input the argument list. Okay, going back to the program, I chose to input the starting and ending value on the command line because I'm going to write a script to invoke this program 4 or more times simultaneously, doing tests over different ranges to generate a load on the computer for benchmarking. We're going to test 1, how long they take. Number 2 is we're going to test the scheduling algorithm in Linux to see if the programs get sent to the fastest processors. Remember, we got an 8 processor system here. 4 of them are 2.4 megahertz and the other 4 are 1.8 megahertz. I do not want these programs to run on the slower ones. Okay? The universe is not going to last long enough. So what are the two arguments to main? Int argc. The system gives us the number of arguments in the command line, including the program name itself. That's the first one, and and it passes to us with a pointer to each argument. Okay, start of main routine. I should be going along here. You need to comment, so I'll put comment and I'll use the latest version. One of the things about C is there are different standards. The latest one, I guess, is C89, and instead of doing the /splat comment, and then you need a splat slash to end it, we're allowed to put a comment in with a double slash. Okay. And then primes.c, July, what is today, 26, 2023. Chuck Adams, author. Project 001 for Orange Pi 5 Plus single board computer demo. And I'm through. I'm going to clear off the end of that line, so we're ready. We're working with prime numbers. If you did your homework and looked at prime numbers, you saw that they are integer. And they're all positive, and they can be large. They can be very large. So now this is also a test because I'm new to the Orange Pi. Let's see how much the hardware can handle. I'm going to do an unsigned integer. Okay, and I want it to be as large as possible. Long, long, long. I want start and I want end. Now this should give us a 64-bit unsigned integer, which means we're going to use every bit of the 64 bits as a value and not have the high order bit, the leftmost bit, be the signed bit. This should allow us to get numbers that are as large as 20 digits long. I'll show you how to figure out what is the biggest one. All right. Now, I'm going to build this program in sections. So the first section here is to input the starting and ending numbers. So there's a routine which you won't find. I don't think it's in K&R. It's maybe it is. Just go out and search the internet or do a man page on it. SS. I'll do it for you. Scanf. This is the function that I know about. So let's do a man SS scanf. All right. You're going to have to search the internet. Give you some homework before tomorrow. Oh, you note that I just went ape and did two. I'm doing 2 of these a day, but today is Wednesday, and I have a schedule this afternoon to go play a game, and I will just do this one. So scanf, argv1. This is argv0 is the command name, and argv1 is start. All right, and it's a long unsigned. Okay, and I want to put the value into the memory pointed to by start. The way SSScanF does, it says take the string pointed to by argv, convert it into an integer long unsigned, and store it at the location where the variable start is. Okay, pretty simple. And it's something that you will probably use for the rest of your life aperiodically. All right, let's do this. I don't want to type the alignment again, so I do a capital Y for yank, P for put, or place, and then I'll go to the third argument on the line, or second argument, third position, and that is change word end. So I've read in the two values. I'm just going to demonstrate how you input the arguments from the command line. So I'll do a print F %LLU is starting value, new line, and start. Escape to get out of the input mode, do a capital Y for yank, put, change word, ending. You see why I ask, see how fast I can do things with VI, and that's the end. That's the end of the program, so I'll end the program with a right brace, and we're ready to start. Okay. Let me do this. Let me put a comment here. Note that VI, okay, tabs there. It knows that I'm doing a C program because you see it highlighted in green, void, int, unsigned, long. Those are all keywords. And it also does an indent, and it's more than, well, I'll stick with it. Do a / for a comment. Define or declare start and end as unsigned integers. Now, if I do a return, it thinks that I'm in a whole string of lines or comments. I'm just going to put the 1 in there. So I'll do an escape to get out of the input mode. It moves me back to here, and I'm just going to do a capital D for delete where the cursor is to the end of the line. So that's effectively a blank line there. So we're ready to try this program. Let's see, double check for any typing errors. Looks good. So we're ready to compile. So I'll do a GCC. I want to output this into a file which is going to be the executable, the binary. So I'll do primes and do primes.c. Now be very careful that when you do the output there, I said output primes, make sure that you don't put a .c there because this will destroy your source. Okay? Look at that. Typed it in and then got it right the first time. Let's execute it. /primes. Let's take a starting value of 101. That's an odd number. And let's end up, it doesn't matter if I end up on an even or odd number. Well, it depends upon how you write the program. Let's go to 10,001. And so the program read in, scanned, converted to integer, and I outputted the values. All right, now you're at this point thinking, well, that's pretty good. Well, it's not. Watch this. What if I just type primes and I forget the arguments? Segmentation fault, core dumped. The program bombed or didn't execute correctly, something messed up, and the error occurred when I tried to scan in something that wasn't there. So let's do a check. If argc is less than 3, it's an error. I want to do two things. I want to print no what error message do you want? Let's say missing starting and ending values. Idiot. But no. Be nice. And I want to exit. There's no reason to go any further. So I'll just do an exit. And be done. Compile again. Let's use our little shell to save us some time. Up arrow. And find, oops, there it was. Down arrow to go back because I missed it by one letter. We want to compile it again. Whoops. Implicit declaration of function exit. Include standard line. Okay, well, that's easy. Go back up here to the first. I did a 1, capital G. Y, yank this line, place it, and replace IO, change word, LIB, and that will get me my exit routine. Compile again. I'm going to use the other way to get to the GCC command, do a bang, GCC. This says go back through my history and execute the line that started with GCC. What in the world is wrong here? Oh, needs an argument. This is just not my day. Well, no day is, but okay. Exit 0. Bang G. All right. Don't you love the way the computers control us? I hope you get the chance, or you have seen Colossus, the Forbin project. One of my favorite movies, but it's not the most favorite. All right, we're ready to execute. Now, if I do dot primes and I purposely don't put a range in there, it says missing starting and ending values. Okay, let's do primes 1 to 1001. 10,001, okay, that's fine. Now we're ready to continue on. Let's see how I'm doing on time. 39 minutes. Let's stop here because I want you to reproduce what I've done here. Okay, clear this, do an ls, primes.c. Let me print it out let me display it on the screen for you, and you can stop the video and type it in. Nope, you can't cut and paste. You're just going to have to type it in. Now, I could go and put it on GitHub for you, but nope. You learn more by typing. So how do I display the contents of a text file? I do a cat for catenate. Let's see if that's really the name. I think it's, let's look, man cat. Catenate. Oh no, it's concatenate. Well, I don't at one time I remember in the 50s, concatenate wasn't a word, but we have, English is like an amoeba. It moves around and it grows, and we keep adding words to the dictionary, so concatenate is a valid word. I just saw a movie last week called The Genius and the Madman. It's done by Mel Gibson and Sean Penn. And I'm going to put that in my top 5 list of all the movies that I've ever seen. It's a beautiful story about how the Oxford English Dictionary came about. And both Mel Gibson and Sean Penn were just great in the movie. Probably didn't do much at the box office, but the Oxford English Dictionary now, I looked it up, is 20 volumes and it costs $1,300 American. If you would love to be a benefactor, I would love to see it. I don't know, it'll never be digitized, I don't think. Oh, send it to me and I'll digitize it. Anyway, so catprimes.c. And there is, in beautiful black and white, a copy of the program. How many lines is it? A new command. If you have a text file and you want to know, you can do the ls-l on primes.c, and it says that the file is only 538 characters. Okay? But there's another command called word count, wc primes.c. And it says that primes.c is 27 lines long, has 77 words, which is, it just separates everything by white space, which is tabs and blanks and carriage return. So it's 77 words and it's 538 characters. Okay? So another command. And in your little notebook or your journal, write these things down. Also, read the man page. In the early days, there was a thing, RTFM. Read the manual. And the administrators and experienced C programmers and Unix users always did that to the newbies. RTFM. So WC prints new line, okay, which is, there's a new line at the end of every line, word count and byte count for each file in the list. So if I did word count for goals and primes, it would show me goals in pseudocode has 14 lines, 41 words, and 329 characters. And then primes.c has 27 lines, 77 words, 538 characters. And then it gives you the total for both, that there's a total of 41 lines, 118 words, and 867 characters. So it's a useful utility. Unix or Linux is built on the premise that it is better to have a whole bunch of commands, a whole bunch of tasks, a whole bunch of apps that do just simple things than it is to write one huge program that does everything. Because you can't write a program that's large, that does everything and doesn't have a bug in it. Welcome to Philosophy 101. Simple screen, I went to 44 minutes, 3/4 of an hour. I get wordy. I apologize. Keep coming back. This is the end of lesson 5. Thank you for your time. hope you have a computer to do the exercises on, or you're making a list of things to do when you get your computer. Maybe I should just, nope, I can't stop. I started, I'm like a snowball coming down the hill. There's no stopping me now. Thanks again. See you tomorrow.